we can rewrite this as the integral of 12 multiplied by 3x plus 1 to the power of minus a half. So square root is to the power of a half, bring this to the top, and then we get minus a half. This is now of the form of a multiplied by bx plus c to the power of n, where n is not equal to minus 1. If it's equal to minus 1, we have to use a different method. If it's of this form, then our solution will be of the form of bx plus c to the power of n plus 1. It may be off by a factor. We're going to work out what that factor is. So in our case, we would need to raise the power of 3x plus 1, raise it by 1 to make this positive a half. So 3x plus 1 to the power of positive a half. Differentiate this and it should give what we're trying to integrate, though again maybe off by a factor. So we have to use the chain rule, so we can set u to be equal to 3x plus 1, and then y would be equal to u to the power of a half. So differentiate each one of these two things and times them together. The differential of u to the half would be a half u to the minus a half, and the differential of 3x plus 1 would be 3. This is then 3 over 2 u to the minus a half, which is the same thing as 3 over 2 u, which is 3x plus 1 to the power of minus a half. Okay, and that's pretty much the same as what we have here, though there's a 12 there and there's a 3 over 2 here. We want this to differentiate to make exactly this. So to do that, we would have to multiply this by 8. Because if we multiply that by 8, that carries through all the way to the end, and then the times by 8 will combine with the 3 over 2 to make 12. So 8 is just 12 divided by 3 over 2. This will now differentiate to make exactly this, and therefore the integral of what we have here would be this. So final answer, 8 lots of 3x plus 1 to the power of a half plus c.